So now that we have talked about, we've seen anyway that the climate is indeed changing. The climate is getting warmer. The globe is getting warmer. We talked about why that's happening, essentially with the greenhouse effect and how various gases are responsible for that, and they're responsible for trapping that outgoing long-wave radiation, not incoming radiation, right? So now I want to talk about several ideas here. The first of which being that the climate system and these ideas of feedback loops, maybe you've heard of feedback loops before. And then I want to get into the impacts of global warming and climate change. And then we'll finish up with things that we can do to kind of help battle these ideas. So first, it's really important to understand that the planet is comprised of various spheres that all interact with each other. And these interactions and processes, we're really still trying to understand them. Some interactions are really quick to be observed, others are not. So if we break down the planet into various spheres, we have the cryosphere, which is ice, hydrosphere, which is all the water, the atmosphere, which is the atmosphere, the lithosphere, which is the ground, and the biosphere is all living things. And notice we also have the anthrosphere here as well. That means us, anthropogenics, humans, anthrosphere. So some things that are quick to be observed would be something like tropospheric ozone. Yeah, like when we went into the very first lockdown, we weren't driving as much, air pollution dissipated all over the world. Cities in India were able to see the Himalayas for the first time in over 60 years, right? So that's a pretty instant thing. Something that maybe takes a little bit more time to understand would be the interactions maybe between the lithosphere and the atmosphere, for example, or even different processes within the atmosphere, kind of going back to things like, how CO2 and temperature are correlated. Rise in CO2 will give us a rise in temperature, but it's not a very quick process. It takes decades to be realized. So, but there are some processes that we do understand, and they kind of go back and forth in this idea of feedback loops. So we have positive feedback loops and negative feedback loops. On the left-hand side here, we're looking at an example of a positive feedback loop, and positive not meaning good. It means basically that it accelerates a process. And I have a better slide on the next one that kind of will go through this in just a bit. But we also have something called a negative feedback loop. So it basically keeps things in check. So the example here is showing a warming or a more direct sun, which can then provide more DMSs, which is, I believe, dead organic material, something along those lines. Those get released into the atmosphere, which can then be what we call cloud condensation nuclei, basically little particles that clouds will attach to, and it makes it easier for them to form. So we warm things up, create more cloud condensation nuclei to create more clouds, which in turn cools things down because we're reflecting more radiation, we're increasing Earth's albedo, things like that. But what we're concerned about in terms of climate change is this idea of a positive feedback loop. So one thing would be if the Earth were to cool, then we have more ice, we have more white surfaces, which reflects more sunlight, which allows us to cool even further. On the alternative side, we can have a warmer Earth, which melts more ice, which has less white surfaces, and we're reflecting less, which allows us to warm even more. The biggest concern here is, obviously, we're getting warmer, right? And it's looking at, we're trying to understand if this process is accelerating. Are we getting to a tipping point? Perhaps you've heard of the planet Venus and that having been the runaway greenhouse effect, essentially. So now Venus is super, super, super warm and not a very easy place to have anything live, frankly. So we don't want that to happen to our planet. I don't think, anyway. I don't, at the very least. So those are some kind of processes that are talked about often within the literature. So now let's get into some of the various impacts of climate change. There's a ton of things that are going to be impacted by climate change. This is not an exhaustive list, but it's kind of the larger, more quote unquote important impacts here. So first, of course, being the retreat of glaciers and sea level rising. Increased intensity of hurricanes and the frequency of severe storms. This is in process of, it's constantly being looked at and studied, but the common consensus is that hurricanes and tropical cyclones will get more intense, and or things like monsoonal rainstorms. If you're familiar with anything in Arizona and the monsoon, or South Asia with their monsoon, or even in Africa as well. There's decreased biodiversity and ecosystem changes, accelerated spread of disease. I kind of touched on that earlier. Changes in seasons and changes in crop yields. Coral bleaching and ocean acidification. This one here is very near and dear to my heart, and I will go further into it in just a moment. Desertification and soil moisture loss, basically drought. Human cost, it's going to cost us a ton of money. Increased wildfires, we live through that here in California. Decreased fresh water supply, not a good thing. And then a big one here at the very bottom is immigration issues. If you have any qualm with any sort of immigration issues at all, there's going to be more of that to come. So I want to kind of touch on some of these, in my eyes, more important ideas here. The first one being that the Arctic is changing. Arctic sea ice has indeed been declining. We've been able to observe that since the satellite era. We've also been able to see that plant growth has been observed 4 to 6 degrees latitude more south as early as 1982. So 4 to 6 degrees latitude is roughly 250 to 430 miles. So that's to say that regions are getting warmer. It's allowing for more plant growth, which can be concerning, right? The permafrost is also starting to thaw, which is releasing more CO2 and methane into the atmosphere. I touched on that idea in the second video, I believe. But what's also concerning with the the sea ice declining is this is getting rid of an ecosystem that creatures rely on for their homes, right? Like maybe you've heard about polar bears and seals and things like that. The polar bears rely on the sea ice to move around as kind of like their ground, right? So if there's less sea ice, then more polar bears are going to not survive. I do apologize that this is a very pixelated screen grab here, but this is a figure from the IPCC's 5th assessment showing sea ice extent has been decreasing and sea level rise has been increasing. So this was an expectation that makes sense, right? But I really want to point out here that it's really, really important to note that sea ice and land ice are two different things. They're both ice, yes, but sea ice is already part of the hydrosphere capacity of water, whereas land ice is stored on the land. So when the land ice melts, that's when we start to add to these growing sea levels. Think of it this way. You have a cup of ice water. The ice is already in there, and if all of that ice melts, it's not going to overflow, right? But if you have a full glass of water and you try to add, full glass of water and you try to add ice to it, then your cup is going to overflow and it's going to be really messy, right? So that's a really, really important distinction that you should know about. Still including this conversation of ice and glaciers, there's this phenomenon of what we call black carbon. So essentially this is soot that is generated by combustion processes and fires. And it's a very, very effective absorber of solar radiation. You can imagine something that's generally pure white like ice, something black is then deposited onto it. Thus, you're making yourself less white. So you're being able to absorb more, you're going to melt more quickly, right? Not a fun thing to have on what we want to be a very white and reflective surface. Next up, there's this idea of ocean acidification. So basically, the ocean is a gigantic carbon sink. There's a ton of processes that go into carbon being absorbed by the ocean. So it's a pretty simple thing. More carbon dioxide in the atmosphere will then increase the carbon dioxide into the ocean, which lowers the ocean's pH. The ocean ecosystems are extremely sensitive to changes that happen really quickly. It can withstand changes as long as they are done slowly, but not as fast as they are happening now. Coral bleaching can be a result of ocean acidification. However, warmer oceans are a larger driver of coral bleaching. If you're not familiar with what coral bleaching is, or coral in general, it's basically these really awesome creatures that's part plant, part animal. So coral has creatures in them that photosynthesize. So during the day, that's how they get their food. And then at night, they have these little polyps that emerge that then catch material that's in the surrounding water. Well, if the water is too warm for the plant aspect of this creature to withstand, then the plant aspect is going to leave. And the plant is what gives coral its color. So when the plant leaves, then the coral is then bleached. And if the creature does not, if the plant part of it does not return, then the coral will die. This is not a good thing by any stretch, because a lot of creatures rely on coral reefs for homes, for breeding, it's a very, very diverse area if it's a healthy coral. I highly recommend checking out the documentary Chasing Coral on Netflix if you have not seen it already. Next, we have a national security issue. So we have immigration. You think that's bad now. It can definitely get a lot worse. It can be something like slow onsets or sudden onset. There are islands in the Southeast Asian regions that have actually bought land on other surrounding islands to, like presidents have bought land to allow their people to migrate to once their islands are underwater. It's a very, very sad thing, but I encourage you to pause this video and have a deeper look at these two figures. But what the heck is going to happen now? What do we do? It's not the end of the world scenario, oddly enough. We have ideas of mitigation and adaptation. Mitigation would be reducing the flow of greenhouse gases into the atmosphere, like switching to renewable energy. We've talked about that a ton in this class, and developing technologies to pull carbon dioxide out of the atmosphere, but there are some drawbacks, mainly money. Or we can start to try to adapt to these various changes. So we're adjusting to actual or expected future climate, hopefully to reduce vulnerability of harmful impacts of climate change. But it needs to be a global effort. We need these global policies to be put in place, and we have passed policies that have worked. We talked about the Montreal Protocol at one point, right? So that was something that is proven to work, and the Paris Climate Agreement is an idea that is meant to be a similar sort of idea. So hopefully things can change. But what are some things that you can do personally to reduce your carbon footprint, or to just, be more engaged in this material just in general? So I call it the 4 R's. You've probably heard of reduce, reuse, recycle for a long time. One added R I want to really touch on here is refuse. So avoid excessive packaging and single-use plastics. Shop locally. You vote with your dollar, honestly, and researching the companies that you buy from and see if they practice sustainability. That's actually part of your homework assignment for this week's material. So, as I said, I could go on for hours and hours about climate change, but we only have so much time for this topic. So I highly encourage you to read the book very carefully, watch and rewatch these videos as needed, and maybe even take more classes on these ideas so that you can be an informed citizen and then pass on this knowledge to your friends and family.